Welcome to the deep dive. Today, we're embarking on a really focused exploration, looking at some incredibly practical insights. These seem to be drawn from, well, NetApp technology exam practice questions, believe it or not. It's actually a surprisingly rich source for distilling essential knowledge. Our mission today really is to pull out the most important nuggets of understanding, give you that aha moment without getting totally lost in the dense technical weeds. Think of it as your express lane, maybe, to being truly well-informed on some critical areas of data management. We want to make these complex topics digestible, memorable for you.
Precisely. And what's really interesting, I find, about using these kinds of sources is how each specific scenario it highlights broader principles in data infrastructure management. These aren't just like isolated technical details. They genuinely represent elegant solutions to very real-world challenges organizations face every single day. So this deep dive, it should help us understand not just what these technologies are, but maybe more importantly, why they matter and what specific problems they solve in different contexts, from disaster recovery right through to data governance.
Okay, let's dive right in then. Our first topic tackles one of the most, fundamental needs in IT data protection. Just imagine your most mission-critical data, right? The absolute crown jewels of your organization. How do you protect that from a catastrophic disaster without grinding all your operations to a complete halt?
Yeah, that's the million-dollar question, isn't it?
It really is. And NetApp has a powerful solution here called SnapMirror. This is their flagship data replication technology. It's specifically engineered for disaster recovery, business continuity, especially for those really crucial databases.
Right.
What truly sets it apart, I think, is its incredible efficiency. It replicates data between on-and-tap clusters, that's NetApp's core storage OS, as you know, using block-level transfers.
And that block-level part is key.
Absolutely. It's fundamentally different from traditional file-level stuff. Instead of re-evaluating and copying entire files, SnapMirror only moves the changed data blocks.
Yeah.
This just dramatically cuts down network traffic. And it ensures very low recovery point objective, RPOs, meaning your data can be restored to a state just moments before a disaster, not hours.
With minimal impact, too.
Exactly. Minimal impact on network bandwidth.
The crucial element to highlight there is that emphasis on both efficiency and frequency. SnapMirror doesn't just, blindly copy data. It does it intelligently. It ensures your RPOs are met with minimal disruption to your primary operations. It really is a cornerstone of high availability for, any serious organization. But I'm curious, for an organization maybe new to this, are there common misconceptions or specific challenges people hit when implementing something like SnapMirror?
Oh, that's a good question. I imagine it's not just plug and play.
That's a critical point.
Yeah.
Yeah, well, SnapMirror is incredibly efficient. It's definitely not set it and forget it. I think many organizations underestimate the planning involved. Things like network bandwidth assessment, making sure your recovery time objective, your RTO and RPO are properly aligned, and even just testing the failover process regularly. That gets missed sometimes.
Testing, yeah. Crucial.
The technology is powerful, no doubt.
Yeah.
But the strategy around its deployment, that's equally vital for real resilience.
That's a great insight. Really brings it down to earth. Okay, let's shift gears a bit. Let's explore a particularly demanding use case. What if your application is generating millions of tiny files? Like in high-performance computing, HPC, scientific simulations, maybe advanced analytics, AI model training, that kind of thing. How do you possibly keep things speedy and scalable when you have this just immense number of small files that can just overwhelm traditional storage?
Yeah, the metadata bottleneck there is killer.
Exactly. This is where FlexGroup comes in. It's a specialized on-NT volume type. It provides a single, massively scalable namespace that's crucial for managing that sheer number of files. It distributes data across multiple constituent volumes, and it's specifically optimized for workloads generating those millions of small files.
And the big benefit?
The big benefit, parallel access. Multiple processes can hit the data at once. This lets you scale performance and capacity independently. It's designed specifically to meet those really demanding HPC requirements where, like you said, traditional storage just chokes.
Right. If we zoom out a bit, the broader implication here. For organizations working with modern data analysis, scientific computing, these environments often involve a massive number of small files. And that traditionally creates huge metadata performance bottlenecks. It's like trying to get, 1,000 cars through a single toll booth simultaneously. It just doesn't work well.
Ah, good analogy.
FlexGroup addresses this by effectively sharding the metadata and the data across many constituent volumes. This allows for just unprecedented throughput and scalability, all within a single view, which is a critical innovation, really, for breaking those I/O barriers in data-intensive applications. Think large-scale AI training.
That really does sound like a game changer for HPC. But does this kind of specialized architecture come with any trade-offs? I mean, are there scenarios where maybe FlexStrip is overkill or adds unnecessary complexity compared to a more traditional volume?
That's a fair question, absolutely. While FlexGroup is excellent for its specific niche, for workloads with, say, a relatively small number of large files, or those that don't demand that extreme parallel I/O, a traditional FlexVol NetApp standard volume type might actually be simpler to manage and perfectly adequate. The complexity of managing multiple constituent volumes, even though it's abstracted away mostly, it does exist under the hood.
Yeah.
So yeah, it's definitely about choosing the right tool for the specific performance profile of your application.
Excellent point. Matching the tool to the task. Makes sense. Okay, so we've talked about protecting live data, optimizing it. What about those times you just need a quick, lightweight copy? For testing. Or maybe a quick backup before a change without duplicating everything and eating up tons of storage space.
Yeah, the instant copy use case.
Exactly. This is where the snapshot copy feature really shines. It's an on-in-tap feature for creating point-in-time copies of a volume. And what's really clever is that it creates these instant read-only copies. And they use very little space initially.
Because it's pointer-based, right?
Precisely. Instead of making a full duplicate, it literally just records pointers to the existing data blocks. New data blocks only get written when changes actually happen, preserving that original state in the snapshot. This makes it incredibly fast to create, ideal for testing scenarios where you need to quickly spin up copies or just as a rapid recovery point before you, say, perform major changes on production.
This brings up a really essential consideration in data management.
Yeah.
How do you manage data without excessive storage consumption or lengthy copy processes? Snapshot copies are just a brilliant example of efficiency. They give you immediate access to previous data states for all sorts of purposes, quick recovery, dev test environments, all without the overhead, the time, the space of full clones. It's about getting the data you need when you need it for specific tasks without all the fuss and the massive storage footprint.
Right. Efficiency again. Okay, we've covered protecting data from disaster, optimizing for speed. But what about the human element? In today's landscape, knowing who is accessing or modifying your files and when they're doing it, that's as critical as the data itself, isn't it? I mean, imagine trying to achieve real security, real compliance without that kind of visibility.
It's practically impossible. You're flying blind.
Exactly. This is precisely where F-policy comes in. It's on NTEP's file access notification and policy framework. It basically lets administrators monitor and, importantly, control file operations in real time. So it tracks events like file creation, deletion, modification actions.
That's critical stuff.
The critical stuff. And the best part, it can send these notifications out to external applications for governance maybe or security purposes. This allows for proactive policy enforcement. It's like having a digital watchman for your files, constantly alert.
What I find particularly compelling about that is the real-time aspect you mentioned. F-policy provides that critical visibility needed for stringent security and compliance. It's not just about auditing after the fact, which is, reactive. It's about active control and immediate response. That forms a crucial layer in any comprehensive security strategy, essential for protecting sensitive info, adhering to regulations, especially with things like insider threats being such a concern now.
It's striking how many of these solutions directly address pain points I've seen firsthand. Like, I remember this one time a client nearly had a meltdown trying to figure out who deleted a critical shared file. The thought of having that F-policy monitoring in place back then, yeah, it's just such a reassurance.
Oh, absolutely. Saves hours, maybe days of forensic digging.
Definitely. But okay, it's not just about who's doing what with the files. What about what's inside the files themselves? Keeping track of sensitive data, personal information, PII, company secrets across these vast, sprawling storage landscapes. Now, that's a monumental challenge.
Huge challenge.
Yeah.
Especially with privacy regulations tightening up globally.
Right. This is where BlueXP classification steps up. It's a key service within NetApp, BlueXP. That's NetApp's sort of unified control plane for hybrid multi-cloud environments. And what it does is automatically scan ONTEP clusters and cloud storage, too. It's designed specifically to identify and categorize sensitive data, PII, intellectual property, you name it.
So it finds the risky stuff for you.
Exactly, finds it and tags it. The major benefit here is obviously helping organizations meet compliance requirements. It classifies and reports on the stored data, giving you crucial insights into data risk across your entire environment. And importantly, it does it automatically.
Yeah, if we look at the grand scheme of modern data management, the growing importance of data governance, regulatory compliance, especially around PII and other sensitive data, it's just undeniable. Blue XP classification isn't just a scanner. You could think of it as an intelligent assistant. It empowers organizations to truly understand their data landscape. It automates what would otherwise be an utterly impossible manual task.
Mm.
This allows for proactive risk management across complex hybrid environments. It really elevates data management from just a reactive chore to a strategic advantage.
So Blue XP classification helps us understand what data we have and where the risks might lie. But beyond just knowing what's inside the files, keeping an eye on the entire health and performance of that increasingly complex distributed environment, especially when it spans on-prem and multiple clouds, that's a whole other ballgame, right? Managing that.
Oh, absolutely. Visibility becomes incredibly difficult.
That's the power of Blue XP observability. This is another NetApp Blue XP service, and it provides a centralized dashboard, specifically for monitoring the health, performance capacity of all your NetApp assets across those hybrid and multi-cloud environments.
The single pane of glass.
The single pane of glass, that's the huge benefit. It gives administrators that unified view for proactive management, for troubleshooting. It simplifies what can otherwise be incredibly complex, fragmented IT operations where you're constantly jumping between, 5 different tools.
That brings to mind a critical challenge,
Mm-hmm.
how complexity absolutely needs simplification in these distributed architectures. Blue XP observability isn't just about collecting metrics, though. It's about providing actionable insights from that unified perspective. And this is just indispensable for maintaining operational excellence in today's hybrid cloud reality, where the cost of downtime or even just performance bottlenecks can be absolutely astronomical. It transforms that scattered view into a cohesive strategy for managing your entire data estate.
Right. Makes total sense. Now, we've focused a lot on ONTAP, which is, foundational for NetApp's whole unified data fabric idea.
Yeah.
But not all data needs are the same. And like you said earlier, not all NetApp systems are built on ONTAP. What about those dedicated high-performance workhorses? Like the E-Series systems, they often live in specialized environments, right, for high IOPS workloads. How do we manage those guys?
Good question. Different beast, different management.
For those, you're looking at Centricity System Manager. This is a dedicated management interface specifically designed for NetApp E-Series systems, think E5700, for example. It lets administrators configure host access, manage the volumes, monitor system performance, all the essentials. Its key benefit is that it's tailored specifically for the E-Series product line. It distinguishes it from the ONTAP-centric tools like System Manager or BlueXP. Ensures optimal management for that particular hardware, which, as you say, often excels in high IOPS, low latency scenarios, database workloads, real-time analytics.
What truly stands out there, I think, is the recognition that different hardware lines have different design philosophies, and therefore they absolutely require specialized management. Centricity isn't just some generic tool slapped onto the E-Series. It's meticulously crafted to squeeze the maximum performance and simplicity out of that platform. Trying to manage an E-Series box with an on-end-tap tool would be, well, inefficient at best. Probably frustrating. It really highlights the importance of purpose-built management for purpose-built hardware.
Right. Tool for the job, again. Okay, so from those high-performance applications, let's swing to the other end of the spectrum almost. Think media companies with petabytes of video files, images, or scientific research with massive data sets. How do you store all that stuff, make it globally accessible maybe, and reach it via a standard API? This is where traditional file systems often just hit their limits, right?
They really do. Scalability becomes the enemy.
The answer here is object storage. This is a storage type designed from the ground up for massive scalability. Makes it ideal for that kind of unstructured data media files, video, images, backups, archives. Its key detail is that it provides access via RESTful APIs. That's the standard language of the modern web, really.
Like Amazon S3.
Exactly like Amazon S3, which everyone knows. It's become the de facto standard API. Object storage can scale to petabytes, even exabytes, and allows for global accessibility if needed. Makes it perfect for workloads needing just immense capacity and flexible access from potentially anywhere in the world.
Yeah, if you consider the wider industry trends, the explosion of unstructured data is one of the defining shifts of our era. It's just mind-boggling. Object storage isn't just another technology, it's really an architectural paradigm shift. It enables organizations to store these vast quantities of data cost effectively, yes, but also access it programmatically. And that fuels everything from content delivery networks, CDNs, to large-scale data lakes for big data analytics. It fundamentally changes how we think about storing and retrieving massive distributed data sets.
Okay, but it's not enough just to store massive amounts of data, is it? You also need to manage its lifespan. Ensure older data maybe moves to cheaper storage tiers without being accidentally deleted before it's time. How do you automate that without needing an army of people manually moving files around?
Yeah, manual lifecycle management at scale is a nightmare.
This is where Storage DREE ILM policy comes into play. ILM stands for Information Lifecycle Management Policies. This is within NetApp's Storage DREE object storage solution. These policies let you define quite sophisticated rules for object placement, retention, and tiering. For example, you can set up rules to automatically move data, say, move older objects to a less expensive cloud tier after 90 days, or even delete them after a set period if regulations allow.
Compliance is key there.
Absolutely. This ensures compliance with retention and accessibility requirements while simultaneously optimizing storage costs. That's a huge win for any organization dealing with large, evolving archives or data sets.
What's truly compelling here, I think, is the ability to automate the entire life cycle of an object based on policy. ILM policies are just critical for balancing data accessibility and long-term retention needs with cost efficiency. They ensure data resides on the most appropriate storage tier at every single stage of its life. And crucially, without manual intervention, which, like you said, is nearly impossible at scale. This kind of proactive management prevents those surprise cost overruns, ensures you're meeting regulatory needs, and frees up valuable IT resources for other things.
Right. Those ILM policies are key to controlling costs over the long haul. But what if the cost model itself is the hurdle initially? I mean, not everyone wants to or can buy all their storage upfront in one big chunk, especially if business needs fluctuate a lot. That's where NetApp's approach to flexible consumption really changes the game, doesn't it?
It addresses a major barrier for many.
This brings us neatly to NetApp Keystone. Keystone is essentially a subscription-based, pay-as-you-go consumption model for storage. It provides a utility-based, on-demand storage service. It offers remarkable flexibility to scale storage up or down based on real business needs, without a long-term commitment or that massive upfront CapEx hit.
Shifting from CapEx to OpEx.
Exactly. This makes it incredibly suitable for, say, startups or maybe larger organizations that just prefer OpEx, operational expenditure, over CapEx, capital expenditure. It aligns IT costs directly with actual usage.
A common concern often comes up here, though. How technology adapts to these evolving business models. And Keystone isn't just a financing option, right? It's a strategic offering. It removes that barrier of large upfront investments, democratizing access to enterprise-grade storage. It lets organizations consume IT resources with the agility of the cloud, regardless of whether their data lives on-prem or in some hybrid setup. However, and this is important, organizations do need to carefully evaluate their long-term usage patterns. While it's flexible, a subscription model still requires consistent monitoring to ensure cost efficiency as needs evolve. You can't just blindly scale indefinitely without checking the costs.
That's a crucial point about the ongoing management, even with flexible models. Great insight.
We really hope this deep dive helps you continue your own journey of discovery.